Hey Tube, welcome back. Today we continue our course in System Design Fundamentals. Um, Today we will talk about the cache. The cache is it's basically a temporary storage area that stores the result of expensive response or frequently accessed data in memory, so that the subsequent requests are served more quickly. So let's just take an example and see how that will work. So let's say that we have let's make everything white. Let's say that we have a server and this server, like, normally will try to connect with the database directly. And let's make this not red, white. We'll connect with the database. And this where the cache come to play. So basically the cache, it's in-memory storage that will try to access, because it's in memory storage, it's way more faster than a normal database. So basically it will try to store in it the frequently accessed data that being served, that the server ask a lot, and instead of the server ask the DB directly, it try to ask the cache, and this improves the system performance and improves the latency. So let's say that the server try to get a user ID with IDs of 12, for example, okay? And when you try to get this ID, this user will try to search in the cache. If the user couldn't find it, it will get it from the DB, and after that will be stored. The value will be stored in the cache. So in the future, whenever the server want to access the user with ID 12, it will not have to go to the DB again. It will go to the cache directly, and this improves the performance. This is also reduce the workload on the database, because the cache takes some of it, and this overall improves the latency. So the cache tier is temporary data store layer, and it's much faster than database because it's in memory storage. And the benefits of having a separate cache tier include better system performance. It's also have the ability to reduce database workloads, and also the ability to scale the cache tier independently. So if the cache, we have a lot in the cache, we can just increase it and add more servers of the cache tier, so we can serve them as we can. And so when you have the cache, you have to consider some things. So first of things, how the cache work. We said before, we first talk about how the cache work and what is the cache. Cache is in memory storage, and how the cache work. The cache is try to store the frequently accessed data, and the server, instead of asking the DB for them, it will try to ask the cache, and this is improve the performance and reduce the latency and the workloads on the DB. And we want to put some consideration for using cache. For example, we should decide when to use the cache. Like, consider using cache when the data is read frequently but modified infrequently, because as you can see, if the data here is not modified that much and it's read a lot, it's a good idea to store them in the cache, because the cache, it's separated storage. So if the data is modified frequently, that means the data in the cache, it will be still data. It will not be a true data. So we should consider using cache when the data is read frequently but modified infrequently, since cache data is stored in violated memory. A cache server is not ideal for persisting data. Like, for instance, if the cache server restarts, all the data in memory is lost. Thus, important data should be saved in persistent storage. This is a second thing also. We have the expiration policy. We should talk about expiration policy, because it is good practice to implement an expiration policy. Once a cache data is expired, it's removed from the cache. When there is no expiration policy, cached data will be stored in the memory like permanently forever, and it will make like it could lead to like a steal data, or data is not true anymore, because it doesn't does it the data in the cache doesn't match the data in the DB anymore. And also it's good to not make the expression policy too short. So if it's the expression policy period is too short, that means we will update the cache too much, and we will try to make the cache empty too much, which will lead us to whenever the server try to connect with the cache, we'll find the cache empty. We want to talk about the consistency because it's one of the main thing here that this involves. Like, we want to make sure that data are consistent, because we store data here in the cache and we have the data in the DB, and we want to make this data consistent with each other. So this involves like keeping the data store and the cache in sync. Inconsistency can happen because data modification operations on the data store and the cache are not in the single transaction. So basically, when scaling across multiple regions, maintaining consistency between the data store and the cache is challenging. And the thing that we could do is that when the data is changed, you can just search for it in the cache and try to change it directly, and you could just maybe like restart the cache, the part of the cache that serve anything that related to this table or this data. We want to also managing the failure. Like right now, let's just to go back with everything. Right now we have a single cache system, and this is we can call it a single point of failure, because if this cache system went down, everything will be down. So a single point for like a single point of failure as a part of the system, basically, that if it fails, it will stop the entire system from working. As a result, multiple cache servers across different data centers are recommended to avoid a single point of failure. So we can just create multiple cache servers across the different data centers and across different regions. So basically, when one of them has been down, we have 3 more to work with them. The other thing that the execution policy, like once a cache is full, any request is add to the items to the cache might cause existing item to be removed, and this is called cache eviction. So this one we could use like least recently used. Like it is important. It's the most popular cache eviction policy. So when the cache it's full, you have add a new item to it. The old item only will be removed, and the new one will be there. So this is how the cache actually work. But let's just try now to put the cache in our system. But I guess it's easy. You can see it because we try. So this is our system right now. And let's try to put the cache. So I'll try to make this, copy this and copy it here. And I will call it cache, not DB. And I want to make it, let's give it a different color. And the web server will connect with the cache. So let's talk about what will happen here. So first, the user try to get the IP address of the load balancer from the DNS. The DNS sends the IP address again, the IP address to the client. Once the client get the IP address, it will try to connect with the load balancer with the HTTP request. The load balancer will try to distribute all the incoming requests across all the web servers that we have. And the web servers, when they get the requests, they will try to do one of two things. They will try to make a write request to the database, or try to make a read request to the data slave or data master. So instead of any read request, we try to search for the DB slave database, the slave database directly. We try to search in the cache first. If the cache have the data, we'll try to return it back to the server and we turn it to the user, and this will improve the latency and this will improve the performance and also will reduce the load on this database. If the cache doesn't have the data, we'll get it from the DB slave and we store it in the cache. And this is how it will work. So that's it for this video, and I hope you like my content. If you like my content, make sure to subscribe and hit the notification bell so you'll never miss a video, and see you in future problems.